Good evening, all. Today, our speaker is Andrew Bastin, a distinguished open source innovator and the head of engineering at Vibrant Lab. A visionary technical leader, Andrew specializes in building scalable data synthesis pipelines for frontier large language models and shaping developer tools. He is widely recognized as the co-founder and former chief technology officer of Hopscotch, a globally renowned open source API development ecosystem. This session will dive into his deep insights on NixOS and the Nix Package Manager, offering a masterclass from a true industry expert. With that, I will hand over the session to Andrew to begin his class. Thank you.
Thank you all. So before we kind of like start on the session, I wanted to kind of clarify on two things. One is, does everyone speak Malayalam here? Then I think it is just easier for me also to kind of like switch to Malayalam. So show of hands, does anyone have issues with me speaking in Malayalam? Well, like, is there any issue with that? I'm assuming everyone speaks Malayalam here. Okay. I mean, if you want me to switch over to English, do let me know. But I think for the benefit of everyone here, I think it'll be more easier to kind of like switch over to Malayalam. So okay. Okay. I mean, no. If that is the case, then I can switch over to keep it in English. It's fine. I'm just wanted to know, but like else it's like fine. Thanks for letting me know, guys. Okay, cool. I needed a couple more like answers from the audience. It's mostly that hey, I'm expecting you guys to kind of ask questions and kind of like insert things because not a lot of people are familiar with what NixOS is. And what Nix does and what is the advantage. And it is one of those Linux distros or like these package managers that, it's a bit more like, I won't say it is like very mainstream or tries to be mainstream in terms of like operating system, because the advantages of NixOS, while it's cool, it's not something that is needed for you to use a computer, for example. So I just wanted to kind of like explain it in the terms that you might understand so that we kind of like have the same vocabulary as much as possible. So I will just ask for show of hands. I think Jitsi has a feature where you can raise your hand, right? Or like you do a thumbs up or something. So can you, so I just wanted to kind of gauge the audience and see like how many of you are like normally on Linux or like understand like what things are and generally the gist of it. So I think I'll just start with like the first question, which is like, how many of you use Linux distros, even if you haven't installed it in the system as like your main OS or something, even if you have something like a virtual machine or use something, so that, yeah, I would say the percentage would be, I am familiar with Linux and I know how generally Linux systems work. Cool. I'll just give like a couple of seconds for people to raise their hands if they have any. Cool. Cool. Okay. So not a lot of folks, but it's fine. Cool. Just wanted to know. Okay. That is the first set of that's the first question. Next is like, what all distros do you guys run? Like, what do you guys normally run as like distro? So do you guys run? I'm expecting you guys to be mostly within like, okay, we have a Fedora person here. Kali and Parrot, okay. Arch, cool. Awesome. That's actually pretty awesome to see. Cool. So because of the, thanks for responding. Because of that, I have like an idea now, like in what terms I had to explain this talk and go through that. Also, another disclaimer, for the most part, so I gave the same talk at NIT Calicut and FOSS Meet in April. So this is basically the same talk. I haven't changed much. I will just go through things a little more faster. So especially the Nix part of the discussions a little bit more faster, so that that is the little bit more boring theory side of things. But after that, we'll kind of get into NixOS, and I will show you around a live NixOS system and do some modifications and get to some more interesting parts of the conversation. Oh, wait. Hello? You can hear me, right? Can I just confirm you can hear me? Yeah. Okay, cool. Hold on. Yeah. Okay. Had a technical thingy here with the headphones. So, okay. I think let's actually kind of like start with the thing. Let me start by sharing the screen. Cool. Awesome. You guys can see the screen, right? Just confirming.
Yes.
Yeah, okay, cool. All right. Cool. Let's see. Cool. Okay. So, by the way, just FYI, like you are seeing the computer you are seeing the talk from is also like running on NixOS. So that's that. So yeah. So the idea we are talking about today is like Nix and NixOS, and NixOS is the main topic that I want to get into and kind of like introduce to you guys. But before I actually explain NixOS, I had actually start with explaining to you Nix, because the point of NixOS is basically if Nix controlled your whole system. So if I had to pitch that to you, then the question, then the thing is basically like, how do I pitch that to you if you don't know what Nix is? So I'm going to start with to help you kind of like get a bearing on that, and then from there we are going to kind of go into NixOS and show all the cool stuff that NixOS can do. So there is like a small set of foundation and that sort of stuff. Then another heads up before going into it, I promise this is the last heads up, is I am expecting a little bit more questions because NixOS is very weird. Nix is very weird. So I'm expecting questions. So if you have any questions, you can ask it. Ask it in the chat. I have the chat open so that if I see that your chat is like makes sense and it's very interesting to the question to the audience, I will kind of like take it on then. Else, if the chat is else, I will kind of like try to clear it up at the end where I will have some dedicated time for QA. So yeah, with that in mind, I'm done. I got an intro. Thanks for the intro. Yes. So I'm not going to spend a lot of time just to explain about me, but because I think the intro was like pretty apt. So I'll just start with the Nix propaganda. Cool. Yeah, and also another thing, I saw that there are arch people here. One of my main this thing is that arch people with NixOS, arch people like against like a lot of reasons why people take arch is like customization, having the latest packages, and like being able to modify and make the system as your own. I have a particular this thing, especially against arch people, because arch people are the ones who I try to convert the most. So I will be saying some stuff against us, or like sometimes I say a joke which is a little bit edgy in terms of like Linux this thing. And as Linux audiences are generally, I will be saying a little bit flame war stuff. It's fun to have flame wars, so but just like FYI, I'll be trying to be doing those things. Cool. So we did that, and so to start with the thing, we had to start with what is Nix. So a very easy way to kind of understand Nix and also to not understand Nix is basically Nix builds. So it's a build system. So what Nix can do is basically build some software. So build as in, like, if you might have seen something like make, or there are some other web systems like that. Like if you're using JavaScript or you do web development, you have some build systems around JavaScript's ecosystem. Those are mostly called bundlers though, because front ends need bundlers. But like similarly, Nix is a build system, and it can kind of build any version of any software in any machine. Now, what does that mean? That's what I'm going to try to kind of elaborate initially, but this is the more easier, like, 2-second pitch of it. Now, there's a star at the end of any machine. And that's basically for the entire statement. There are some things that Nix can't still prevent. For example, Nix can't beat physics, and Nix can't beat things not existing before the thing, or like something not working back and forth. But the idea is Nix can build any version of any software in any machine. So the actual Nix, the package manager, it started out as a PhD thesis by this guy named Elko Dolstra. So the idea of it basically goes around into, so if you have to kind of give you a gist of like how packages, how software is packaged, especially between open source and closed source packages. There are some things that you want to kind of know. So, for example, let's say I have some Rust code. It's like I am a developer. I made an application in Rust, right? I cannot just give the user my Rust source code and say run this, right? I had to compile it into an application, and that application is installed into the user's computer, and then we kind of run it. Right? So that's what we do here. So we convert it into an application, and then we give it to the user. Cool. So this is how we normally do stuff. So for example, if you are using Fedora, your package manager is RPM, or you use the DNF shell on top of it. But like somebody compiles your Rust code and gets an executable, converts it into an RPM package, sends it over to you, and then it's installed over there. If you are using something Ubuntu-based or Debian-based, it'll be converted to a .deb file instead. So you take the compiled code, converts it into a .deb file, and sends it over. If you are using Arch, you have the same thing. It's just Arch has Arch repositories, and then you use Pacman to install it, and it does the same thing. AUR works a little bit differently, but it's kind of the same story, somewhat the same story there. But yeah, you basically do that. Now, this approach has a couple of issues. So I don't know how many of you will be familiar with something called static linking or dynamic linking. So, for example, in operating systems like Fedora or Debian, you may have noticed, so for example, like some versions of applications, you will see that if you are using this version of Debian or Ubuntu, you had to like pull this version. If you are using older version of Ubuntu, you have to pull this version. So much so that in Ubuntu and operating system, the Debian operating systems, they actually they always have different packages for the different versions of the OS itself. Now, why is that? Is because there is a philosophy on the Debian and generally on Linux distro sites that your Linux, your application should try to reuse libraries and stuff from your OS. So, for example, if you are using something like KDE, your computer comes with Qt. Qt. It's called Qt, but you can say Qt. So you can see that mentioned here. So you can see Qt. Now, Qt is, for example, used by KDE. KDE is written mostly in Qt, and so it's usually installed in your system. So there is this initial concept called static linking, where when, let's say, I want to use some Qt features, then I literally just have the Qt source code compiled and shipped within the app. The problem with that, if we do that, is your app size is going to be bigger, because it's not going to, let's say every KDE application that comes with KDE, for example, has Qt. And so now everyone is going to have their own copy of Qt that gets installed, that gets shared that they just have to use in the system. So the problem is the application size becomes bigger, and because of that you will have, like, it takes more storage. Memory consumption should also be generally more higher. So all of these things will happen. So what Linux distros have generally done is do something called dynamic linking. And so what the dynamic linking does is the library, so in this case like libqt, will be installed as a separate package, and then all of your apps can basically share the same libqt. So that means one advantage is it uses lesser memory, lesser storage, and it's going to be generally a bit more faster. That's the kind of advantage with using dynamic linking. But the disadvantage of dynamic linking, which is the major problem that we see, is that, let's say, as a developer, I had this version of libqt, like libqt 5, installed in my system when I was developing, and then I compiled my application with that. So I think that application works for everyone. But let's say my user doesn't know, my user doesn't I don't know what is running in my user. Maybe they'll be running a newer version of the OS, or some new libqt 6 comes or 5.1 comes. There is no guarantees it will be the same. The OS will link with libqt 5 as much as possible, but like in some many cases that won't be possible, and that is very annoying. So what can happen is like this action of this works in my machine, I cannot reproduce the problem, kind of happens, right? Because we don't know what is running in the user's machine, and when we develop it, it's going to be kind of and when we develop it, we kind of end up in this situation. Cool. So there's another approach that some Linux distros have basically taken up into. If you are familiar about some Linux distros like Gentoo, they do, and generally in Linux, if you don't want to use a package manager, if you want to install an open source project, what you usually do is you can download the source code, run make, compile it in your own machine, and then install it. So that is one approach we usually see. We give the developer gives the user the actual application, the source code. The user converts it into a binary. Or if you're using something like Gentoo, the Gentoo's package manager system itself will just convert it into like a binary, convert it in, like, do it as an automated process, and then we kind of set it up there. Now, this also still has the same issues. So, for example, I am building a Rust application, right? So, what if I am building a Rust application and I tested this application in my computer with this version of Rust C? Rust C is the Rust compiler. So, it's like if you're for C, C++, you say GCC. It's kind of the same thing with Rust, you say Rust C. What if the version of Rust C is different? Usually what happens is developers will have a new version of Rust C, the users might not. If they are using some Debian-based distros, they might be having an ancient version of Rust C, because Debian distros are a little bit slow in terms of getting new packages. So all of these things can happen. So this also has the same problem. Now the only difference is instead of running, the app won't even compile, and that will break things. Right. So this is also an issue that we kind of see when we kind of like build applications and kind of see. So what Ilko's idea is in his PhD thesis was basically this, but also scaling this up. So a way to solve this problem and also to scale this up. Like, imagine you have this application and you are running like an enterprise, and you have a bunch of servers and you want to deploy it into all of the servers. Now, all of the 10 servers you are seeing here could have its own set of configurations, its own set of OS, and we don't know exactly what is running, what is installed, and this whole thing. So it becomes like a lot more complex process to basically make sure things work. So this is what Elko's paper kind of deals with, and this is a problem that we see in software development even now. Right. To prevent this, there are so many approaches that are coming into. There are things like Docker. Docker literally just ships whatever your OS configuration is. Yeah, you can just express it in your Docker file and then just send it over the Docker file, and they run a simulated OS, and in that you get kind of the same thing. But it's all very wasteful, and it's not a very scalable solution for, like, running a general purpose OS. So so that's where basically Nix comes in. And I'll explain to you what Nix does. But Nix's solution basically around this kind of comes in with three-pronged approach. So when I say the word Nix, there are three parts to it. So the first part that I'm going to be talking about is something called the DSL. Now, I don't know if you're familiar with the term DSL, but the idea with the term DSL is mostly it stands for domain specific languages. So Nix, the package manager, uh, the main thing in it is you write these scripts in this programming language called Nix. So there is this programming language called Nix. So when we are specifically say in the community, when we say specifically that we are referring to the Nix language, we say Nix lang. We you write scripts in this Nix DSL programming language, and the package manager executes it. So the to explain about the programming language, I don't want to explain to you the syntax because again, this is all just theory before I get into NixOS. The idea of the this Nix language is to generally call this function. So this doesn't look like, so if you're coming from kind of like a C programming language or Java, there should be a bracket over here, right? You can put a bracket in Nix, but the idea is in Nix, like this is very common. So you just don't need to put the bracket. The language just understands this, that you're calling a function. So it's calling a function, it's giving this dictionary or list, and it's setting the configuration. And the idea with Nix is basically you kind of define this, and this is kind of like a recipe. This is kind of like a recipe for how to build software, right? So the idea with Nix is, for example, this thing kind of says what all requirements are there. So I have this program. I'm building this for this architecture. So this basically means I'm building this for an Apple Silicon Mac. Darwin is the Mac OS Unix kernel. And then I have a source file, which is this thing. So this is just compiling a very simple C program. And I'm saying I need bash, I need clang, and then I have to kind of like emit it in this way. So you don't worry about the syntax and the style here. I'm just trying to give you a proper point. So the idea is you write a derivation, and then the idea is in the derivation, you say what all things you require. So let's say, for example, if I'm compiling a Rust program, right? I say I need a Rust C, right, to compile the Rust compiler to compile the things. Then I might need a shell like Bash or ZSH or something to run the scripts to compile the things. Then if my Rust application uses some native library, let's say it's a game, then maybe I use something like SDL or OpenGL or Vulkan or something, right? So those will all become dependencies. So what we tell Nix is, hey, I depend on these dependencies. And the way Nix works is that when you declare the dependencies, you just don't say, I want a dependency. So that's what like the other distros and stuff do, package managers do. In Nix, what you basically say is the recipe for building that itself. So what that basically ends up doing is, let's say if I write a recipe, that recipe says the entire universe required to build the thing. So if, for example, the Rust compiler, let's say the Rust compiler generally requires the Rust compiler to build the version. But let's say previous version of Rust compiler, you can build it with like GCC or something if it's written in C, right? Then the Rust compiler the Rust compiler's derivation will also be there. And then for like Bash, the Bash derivation will also be there. So you can see here, Clang is being defined. The Clang's definition will be there. And like it will go like derivation down, where everything is pinned. So so my derivation pins the exact same Rust version, the exact same shell version, and even the dependencies. So whatever compiles Rust C, even their basically will also be pinned. So the advantage of that is like I can run this command in any machine that can compile an R64 Darwin binary, it will do that operation, and it will be the exact same operation even if it runs in my computer or it runs in your computer. So much so that if you install Nix in your machine, so for example, in Fedora's repositories come with Nix. So you can do DNF install Nix, and then Nix will be there. You will have to enable something called Flakes. In Fedora, I think it's enabled by default, but like some other distros might not. Arch also should have it in the AUR probably, or maybe even in the main repos. But if you install Nix there, you can even run this talk. So this talk that I'm giving right now, the slides for it is actually just another Nix derivation. So I'll show you how that is actually done. I have this repo called FOSS 26, because this is the talk I gave for FOSS 26, and I have defined a Nix derivation for it. It's a bit complicated, but I have defined a Nix derivation for it, and it will basically run the Nix derivation. And because it's out there and it's a public repo, Nix can actually just run this straight on. So I'll show you how that works. So I can just basically say Nix run GitHub. So pull this from GitHub. And say FOSS 26. I already ran it, so it doesn't need to compile. So I have run. So it will pull that. It will build it in my computer, and I will have the thing up. So it just basically just starts the web server. So if I do a localhost 8080 again, I get that my talk. If you guys want to follow along, you guys can run it in your machine as well. If you install Nix in your machine and you enable Flakes, there should be a feature enabled called Flakes. You can Google search how to do that. I'm not going to be explaining that here. If you enable Flakes, you'll be able to run this command and then basically be able to get the exact same talk, right? Even in your machine. And Nix gives you a guarantee that it will build in your machine. It will be built in your machine with the same OS configuration or like same libraries and same everything as what I have. So Nix will still keep that up, right? Now, the other problem is, as I said, if you are writing a derivation, you had to also say how the dependencies are also derived. You had to say declare the entire universe. The problem is if I have to define how, so for example, this my slides. My slides are written in this library called Slidev, which is a Node.js slide library thing where I can like write a slide as a markdown file, and then Slider will like render it properly. So if you see my build recipe, I need like Node.js and PNPM to build everything. And then I also need a HTTP server. This is a program written in Python to start an HTTP server. So that means I need Python also. And if I were to write the derivations for all of those stuff, it's just going to get like a lot of time. It will be very time consuming and very inefficient because like I had to sit and write how to compile Node. And then Node is written in C and C++, if I remember correctly. Then I had to say how will I compile the C compiler and everything. So it starts becoming like very big, very heavy that, there's not a lot of point in doing that. So the idea is basically to prevent that. There is this. There is the other fork in Nix, which is called Nix packages. Now, Nix packages, the name will say it's kind of like a package repository, which it is. The Nix packages, but it is also sort of like how you have a standard library in Python. It's kind of the standard library in Nix also. So there are functions. There are functions that, again, as I said, Nix is a programming language, the language. But it also has like functions and that sort of stuff built into the language. And Nix packages define some like common functions that everyone uses, like how to split a string, or how to reverse an array, or like join an array together, do like a flatten operation or something like that. So Nix packages defines that, but it also stores all of the packages as Nix derivations themselves. So if, for example, there is this website called search.nixos.org, here I can search for a package. So for example, if I'm searching for Node.js, there is going to be Node.js, the package. Now in Nix, you can also see the derivation source code. So Nix packages is developed in GitHub. So you can just see here. And you can see this is the recipe for how to build Node.js, right? And it'll also be like basically be pinned. So that's Nix packages. Now, Nix packages is one of the world's most biggest package collections. So, for example, now when I say that statement, it needs to be kind of put into kind of like a graph to understand the scale of things. So this is Repology's graph of basically what each software libraries kind of have, and the x-axis is basically saying how many packages are there in the repo, and the y-axis is basically saying how up-to-date the packages are in the repo. And you can see Ubuntu basically staying over here on this area. Fedora is about here. AUR, Arts AUR is over here. But you can see AUR has only caught up to where Nix packages was. So this basically means this is Nix packages as of November 2023. So AUR is caught up here. The actual current release is basically around here, which means, there's a lot of packages, like we are here and they're there, and all of them are more up to date than the AUR packages as well. So it's basically, it's getting, it's actually like insanely big. So yeah, it's the biggest package collection that we have of open source projects and non-open source projects also. It's also the stdlib for the language. There is a wrapper that comes around. So the derivation function you saw, it's an actual function within Nix. The point of the language is to call the derivation function because that is what does the work. But the derivation function is very raw. So there is like a built-in Nix packages version of a derivation function that does even more work for you. But like this doesn't matter. And it also has like all of the functions that you require for like writing good like Nix derivations basically. So the way Nix works and these things kind of allow you to do some cool stuff with Nix. So I will show them around. And this also is applicable to NixOS. So because in NixOS, the main way you deal with packages is with Nix. The same thing kind of happens. So for example, Nix doesn't have a concept. As a package manager, Nix is very weird because Nix doesn't have a concept of installing software. So what does that mean? Basically, in Nix, I just say that I want a piece of software and I kind of get it. I'm sorry. So I am in my system. In my computer that I don't have Python, for example. I don't write programs in Python much. So I don't have Python installed in my machine. So there's no Python. But let's say I quickly want Python, right? I can run this command called Nix shell, Nix packages. So in Nix packages, I want Python. Okay, I had to say specifically which version of Python. So it's the Python 3. And now if I do something, I have Python in my machine, right? So now I have Python, I can compile and run Python applications, right? So this is not installed in my machine actually. So if I exit this, if I run Python, it's not there in my machine, but when I kind of came in, I have, when I kind of came into the shell, I have Python. I had said Python 3, Python version, right? So this is called ad hoc shell. So we are in a shell. If you are familiar with how Python development works, this is sort of similar to how a VN works. So it's kind of the same thing. So mm, you can even do another thing. So again, as I said, this is not installed in my system. So what if I want two versions of Python at the same time? I can do something like Nix shell, Nix packages, Python. Now Python, like packages are like a very complicated thing, because like in Python they can break programs between Python versions. So let's say I have Python 3.14. So this is Python 3.14. So it is going to pull Python 3.14 into my computer, because I don't have that installed. Now if I do Python version, I have that. But at the same time, I can maybe start another shell and be like Nix packages Python 3 or 309 or something. I think it'll be like 310 or okay 311. And it's going to pull that, and then we can see it's going to do a run Python version. It's like 311. So I can have two versions of Python actually running at the same time in my machine. So this is what I meant by like it's not installed. It's not like actually installed into my system. Depending on the situation, I can just say that I want Python. Nix will summon Python and give it to me, and it kind of is there. So this is actually really cool. So there are some really cool applications to this, like how we do kind of like development with Nix and cool stuff, which is the next stuff that I want to kind of show, which is called dev environments. So for example, let's say this is my blog. Okay. Now my blog is written using a program that I wrote called Hugs. Okay. Okay, it doesn't have a version comment. So this is the program that I wrote, and I packaged it with FOSS as well. I made with Nix. So the funny thing is, Hugs is also not installed into my system. The only reason I have access to it is because I actually used another thing. Let me actually go here. Let me actually do this so that it stops doing that. Cool. If I actually try to run this in here, it's not going to work. But if I can just bring in Hugs by saying Nix develop. Now this starts up something called a dev shell. So what this Diren thing did before was automatically start my dev shell. But this basically starts my dev shell. And now if I actually say Hugs, it will basically know that it's there. So you can sort of think of this as, again, like a VM, but not for Python. It works for everything, where you can say that, like, okay, these are the tools that are required for me to develop an application inside, develop an application that I want. So here I said that in my derivation, I can actually show you the derivation itself. I can show you the Nix. Here I have said that I need a dev shell, and I said in the dev shell that I need Hugs. So I can basically get Hugs, right? I get a shell with Hugs. So if I go into that, it'll work. This is so much so. This is actually how even Nix packages is built. So I am a I am a contributor to Nix packages. So I can go to OSS Nix packages. And this is my local clone of Nix packages. Nix packages is a big repo, so I'm not going to spend time. And when I develop for Nix packages, I do some code review and that sort of stuff. I also just type Nix develop, and it will basically build the dev shell that Nix packages developers should use. So the advantage of that is, like, in you can imagine it to yourself. You are working on a project, and then you have your friends. The friends have their own laptops with their own configurations and apps installed. That, I always have situations in my work where it's like, hey, did you install this package? Did you make sure this is the exact same version? In Nix, that is not even something that you think about. You just say that this is a dev shell and tell everyone to basically use Nix and say use Nix develop when you develop. There are even tools to automate that. But if I do that, so currently I basically have all, now I have in the next dev shell. So if you do that, everyone will get the shared set of things. So whether whatever version of Node.js you have installed in your computer, when you're inside the dev shell, the Node.js you get is the standard version that's set by the dev shell. This is not running inside a container. This is running in a live this thing. So a lot of people, what they do is say ship a container for development. That means you cannot use your tools, but you can still use your tools in Nix because it's not a container. But it's still like the exact versions of packages that are said. So for example, for us Nix package reviewers, we get stuff like Nix packages review, which is like a program for us to review. It's not an application that's there in my computer, right? So really cool. Everyone gets on the same page. We don't need to communicate. We don't need to kind of sit back and forth. It's like so much more smoother to do it in Nix, right? It's a really cool thing which you can kind of do. Here's the main thing. We came to the initial argument of like Nix builds any version of any software on any machine. So what does any software mean, right? So in our head, like when we say software, like automatically in our head, it is like, okay, an application or a library, right? But everything that we use in our computer is software, right? So Docker image. So if you run a Docker container, isn't a Docker container a software? Yeah. Nix packages can Nix can build Nix can build Docker images. So here is basically a function where you can build a Docker image. And the funny thing is, Nix is so good at building Docker images. These images will be smaller than what Docker can build. So you can just say what dependency will build the Docker image. So you can kind of do that, right? It's really cool. I'm not getting too much into it because that's not the point. So the question is like the ultimate software that you can build is the operating system, because operating system is also a piece of software. So why can't Nix build an operating system? So that is basically what NixOS is, and that is the third part of the Nix fork. Now, to give you a very brief representation of what NixOS is basically just an operating system, a Linux operating system that Nix builds. And Nix, basically, you define a recipe, your derivation for your entire OS, and Nix basically builds that OS for you. So that is basically the gist with NixOS. So with that, I think we can now get into like a very good demo of NixOS and kind of like get you into kind of the things. Cool. NixOS demo. So I have a virtual machine system for this. So let me just bring that up. Because I can modify my actual machine, but like, I don't want to mess around with this for now. So I think this should start if I click on it. Yeah. So this is a NixOS machine running in a VM inside NixOS. So this basically just has XFCE. So just think this is a fresh Linux OS right now. It just runs XFCE. It runs NixOS. I think I have Flex enabled, so I can even do what cool people do, which is run fast fetch or neofetch. You can do neofetch. See, it'll probably pull everything that neofetch wants. Again, neofetch is not installed into the system now. Neofetch is not even there. If I do neofetch, it's not there. Cool. So you can see it's a very basic system. It uses XFCE and that sort of stuff. Now in NixOS, there's no concept of like installing a software like Nix, right? So the way it is kind of defined is there's this folder called etc NixOS, and I'm just going to go to sudo. And I'm just going to have that. Now, for example, I can get, I use NeoVim as my code editor. So sometimes I just want to kind of like see, open files and edit them. But, I had to use NeoVim, and the default NeoVim config, if anyone has accidentally gone into NeoVim, is basically just Vim. It's just an updated version of Vim. It's not very easy to kind of like follow. And so I have my own NeoVim configuration. So this is not, very good to look at or anything. So I have my own version of NeoVim, for example. I can do that here. I can even pull that. So my OS, including what you see on screen, is also an open source repo. NixOS config. Let's see. Yeah. Is also an NixOS repo. So if you actually want my OS setup and everything, you can see is what all applications are Android using. All of it is actually defined here. So I have my NeoVim configuration defined here. So then I will be able to see my NeoVim configuration as well. So actually, let's say I want my NeoVim configuration in this machine. I can even do that, like similar to what we did for the FOSS Meet talk. You can just say this. I'm just going to get the mini version of my NeoVim configuration so that it's much more easier. I have already run this because for time's sake, I have basically already run this in the computer, so I can just do that now. But this is the same NeoVim configuration running on a different machine. Is there? Let's say you have a NixOS machine that you are SSHing into, you can bring it over there, and you can still use your own configuration. So you don't need to install anything. So it's there. So this is the same thing that actually runs in my machine. So if I nvim here, I get kind of the same. Same configuration, right? It's the same. It's just running here. It's like super cool, right? Because like I know this configuration very well. I can bring it into any machine that I want. And so if I'm actually going deep into this, you can actually see that like a lot of configuration is actually done here in the Nix language. So you can see that this is a Nix file. So I have said a lot of things here, like my time zone is defined here. What my locales are defined here. The fact that I'm using XFCE is defined here. So for example, if I want to switch to KDE, for example, I just remove this line and I just change this to KDE, and then I have KDE. Then if I apply this into my configuration, it basically gives me KDE. And then similarly, like I'm doing printing, I have pipewire, all of those kind of stuff are there. This is the user defined here. And I have said that I want Firefox, and because of that, Firefox is there. And this is how kind of system works. Even the firewall is defined here. My firewall is there. I said I don't want SSH, so OpenSSH is not there, and so on and so forth. So the entire OS is basically defined here, which is actually pretty cool. Yeah, okay. It's because of that, it's actually really cool. And this is the kind of idea with NixOS. So you just write this configuration file, you update it to do what it wants, and when you apply it, you get basic with OS. So for example, to kind of give you a demo here, let's say I want an application, something that I can get really quick. Could be something like Git, right? Git is a very easy application to pull. It's a very small application, so I'll do that. So I made a change here, but changing this configuration file by itself won't give you anything. So if I say Git, there's no Git. So how will I get Git? So now we have updated the configuration, but we haven't told NixOS to kind of Nix to build the new configuration. So to do that, there is this command called NixOS rebuild switch. Okay, so if I run this configuration command, it sees that, hey, you updated the configuration. So I had to match the system with this configuration and match the system with this configuration. And if I do this, now my computer has Git, right? So this is how you install. Again, this is not generally installed. That idea is not the same in NixOS. You basically declare that I have Git in my system, and then the OS will give you, then Nix will give you an OS with Git. So you are basically creating a new Linux distro for yourself. That's basically what is happening. So if I, for example, remove Git here and do NixOS rebuild switch, NixOS rebuild switch, it's going to do the processing again. And if you do that, now if you check, you do Git, there's no Git, right? So yeah, you get the idea why I'm saying that this is not like installing. You are declaring that my computer has Git, and the Nix is like, okay, how can I make it so that Andrew's computer has Git? pulls the package, connects it all together so that you have a version, you have an OS where you have Git. So it's not like installing. So that's there. The normal stuff still works. So you can still do Unix packages Git, and then you have Git again, right? Temporarily you have Git again, but the OS doesn't install Git. Now, another thing with NixOS, and this is where Arch people, I'm trying to pitch to the Arch people even more, is I also used to use Arch. And one of the reasons why I left Arch is because when I started getting a job, I wanted my system to be stable. I didn't want my system to break after an update and things kind of messing up, which is what Arch people kind of like end up doing, right? So in Nix, you don't need to worry. Hello, can you guys hear me now?
Yes. Now.
Yeah, I had a thing with my Bluetooth, so that is a thing. Let me just reconnect the screen share and let's proceed. Hello. Yep. You guys can see the screen, I hope.
Yes.
Recording is on.
Bluetooth, it's not a Bluetooth issue. I am writing my own Bluetooth driver for AirPods, and it's an Android skill issue, not a issue with NixOS per se. But okay, I mean, fair point. I guess we'll fix that. This is what happens when you write your own Bluetooth driver, guys. Okay. So I basically decided to just remove these lines. So because if this is not there, I am not going to even have a UI. I'm just going to do that still. Switch and should switch, and if I do this and let's say I reboot the system. Okay. Did I not save the file? Yeah, it crashed. So the reason why it crashed is we literally removed XFCE. So there's no XFCE in the system, right? It's kind of dumb. We broke the system. Now normally, so this and even worse stuff is what Arch people usually deal with. Normally they won't even reach the screen, but in Nix you don't need to worry about it. Because Nix knows that like your thing is based on the OS, it's giving you a new OS every time it kind of restarts. I mean, when you kind of do a NixOS rebuild. So what I can actually do is I can actually time travel into previous versions of the OS. So I can be like, okay, the generation 23 is where I broke the system. So I can be like configuration 22, and I can come back in. And I'm back in. I'm inside XFCE. I'm back. It's recovered. It's still the same OS. We are just one generation behind. So I have recovered the system. I can do my work, and more importantly, I can figure out what broke. Right. So I can just go back to etc NixOS. I can do this thing. Oh, I had to. GitHub, Bastin, NixOS config, and then mini, and then I can fix this. Whoop. And I do NixOS rebuild switch, and it's going to basically build the OS with XFCE again. It shouldn't take much time. It'll just configure this up. Now, if I reboot the system, if I come back, we should have XFCE again. It's really cool, right? I cannot break my system, because even if I break my system, I can just go to a previous generation, fix the thing, and then come back. It's more cool when you use something like Git. So my configuration, for example, is there in GitHub. Break my system, I can just go to the previous commit, apply that, fix it, and come back, right? And then maybe when I'm free, I can just basically come back and do this. So you can hack your system, hack in the sense you can modify your system how much ever you want, which is the reason, I am an employed person, I run an engineering team. I still have the freedom to mess with my Bluetooth drivers, mess around with these things. In a pure Linux fashion, I can mess and break my system, but still I can still go into a work. So after this call, I have a meeting, and I can join that meeting even if my Bluetooth driver is broken. I can just go to an older version of NixOS where the Bluetooth driver was not messed up, and it'll work. It's really cool, right? So those are really cool to NixOS features. Another really cool thing that I can kind of show you is like another really annoying thing about like NixOS or like running an Linux OS, especially laptops, is you have to configure your drivers, right? And that is annoying. Maintaining drivers is annoying. So because you are following some random person's guide, that guide might be outdated. And you have to set up everything. If you make a mistake, you don't know that, so it gets all messy. In NixOS, again, your OS system is code, right, that you can modify. So what Nix community has done together is we have built this repo called NixOS hardware. Okay, similar to how I brought my Vim configuration over, people who run NixOS in their machines contribute their driver setup into this repo. So for example, my laptop is a ThinkPad P14S Intel Gen 5, right? Is basically here, and they have configured how it works. So mine has an NVIDIA GPU. That NVIDIA GPU needs to be maintained, needs to be figured out. The Intel power management. I have a fingerprint sensor. The fingerprint sensor drivers need to be installed. So with this, what I had to just do in my system is literally. So this machine is named Fern, and I have basically said in configuration.nix that I use the drivers from here, and then the community themselves will share drivers and make sure the setup is the same. And this is the best setup that the community has figured out together. You can contribute, other people can contribute. And the amazing thing with Nix, because it's all code, when the repo updates with better configuration, better support, I can still, I will get that thing up live. I don't need to look into documentation, know that there is an updated system. It just normally comes because it's all just code. And then you can also share out things. So we at Nix community, we are like very live in like helping people out. And it's also part of our proper to kind of like share stuff and basically be that. And we can easily do that. For example, in our community, I have a friend named Aditya. Sometimes, like when I set up my configuration, Aditya is the one who introduced me into NixOS. So I think he moved to Codeberg. Aditya runs NixOS, and I can see what his configuration is here. I can learn from his configuration, bring that to mine, and it's really nice. So we can share and kind of like work together, and that's kind of a NixOS kind of philosophy. So that's modules, generations, NixOS hardware, and then the other thing is, okay, Ubuntu people are generally like, Ubuntu Debian people are like, okay, we need to have older stable version of packages. Arch people are generally like, we want the latest packages. Now the problem is you don't have the ability to choose stable packages in Arch and very unstable packages in Debian side. It's very difficult because something can mess up in between. That's not a thing in NixOS. You can mix Nix packages together. So for example, NixOS kind of follows the same kind of situation as Ubuntu or Fedora, where they have a release every 6 months. So it's kind of the same. My computer runs the latest 26.05 release, but some packages that I use. For example, I work in an AI company, so AI research lab. So I need all the AI tools sometimes. So I can actually get the latest version of those things, like all of the tools that I want the latest version. So like for example, Thunderbird, Slack, Side, all of these apps, I want this visible. And this will be the latest ones. But for example, Firefox and NX and these like core level stuff in my system, it is basically using whatever is stable rather than the latest one. So I can even mix and get the best of both worlds, which is actually really cool. That's a very NixOS thing. So you can do that. Next is like there's a thing called Home Manager. Home Manager, I'm not going to go deep into Home Manager, but you are seeing Home Manager in action here a bit. It's like all of my configuration files are also written in Nix. So for example, when I set up a new machine, I have a couple of things that I always use. So for example, I have a set of Claude skills that I use. I have Emacs. Emacs is what I write code normally on, not Vim. I have Git here. Let's see, Git. I have Git here. I need to configure Git. That is all set up and it's there. And all of these configuration files I have written into Nix so that when I set up a new machine, if it's running NixOS, it just sets up. So this, for example, is my second NixOS machine. I bought it last year. And guess how much time it took to set up the computer so that I can use it for daily work. It only took 10 minutes. Just write the things, write the configuration, write the hardware, done. It's basically it. And it configures everything that I want. So it's really nice. So that's Home Manager, NixOS hardware I showed you. Nix packages help us for drivers. This is when you want to go even more bleeding edge, where like even Nix packages doesn't have what you look for. In many cases, Nix packages will have drivers. So for example, sometimes I want the latest NVIDIA drivers if there are like graphics issues. Sometimes it's not packaged in Nix packages. I can just take the function implementation for like giving the derivation and do that. I'm not getting into that too much. It's a technical thing. Nix, the package manager can run in macOS. You have shown it in the derivation. Then there is this project called NixDarwin where you can do the same thing. So I have a Mac as well, and everything my Mac does. I think that is in Winry. Homebrew. So these are the Mac App Store apps that are installed in my computer. If I remove something from here, the app will actually be uninstalled. And this is a Homebrew cast that I installed. macOS is not as good as NixOS, but sometimes I had to use it for work. So I have that. But there also I can use Nix. Then a really cool thing that is a very NixOS thing, this is hopefully the last thing to showcase, is something called comma, which is kind of a shortcut for Nix shell. So if I, for example, know the name of the app that I want, I can quickly kind of summon it. So I just need to say comma before it. So for example, if in my computer I don't have something like, I quickly want like LibreOffice Calc or something. Or like mostly what I use is for something like FFmpeg. I want to quickly convert a video. I can just be like, okay, I want FFmpeg. It will pull FFmpeg for me. Let's see how big FFmpeg is. Yeah, okay. It will pull FFmpeg for me for running this command, and then I can be done with it. Right? I usually use it to quickly get Chromium because I also had to do some web development sometimes, and sometimes I had to test it in Chrome. And as a very sensible Linux person, I will have Chromium in my machine. I just want it when I develop. And this will now pull Chromium and let it run in the background, but it will pull Chromium and I can kind of do things, right? So this allows me to like quickly get the things that I want. I can just like summon it and then I leave it when it's done. So this is not installed in my system. It's kind of like how Nix shell works. Is just a very good shortcut to kind of quickly get it installed. So I don't even run Nix shell. I just run like comma, say what the program wants. Nix knows what program I'm referring to. It will just get that, right? So it's really cool. Yeah, you can use it for this thing. That it's kind of that idea that you can like snap and get into your things. So I think this will pull this thing. Meanwhile, we'll try to go again. And yeah, I think I will try to kind of like finish this before getting into the point, and then I'll kind of wrap up. Yeah, so I have Chromium now, right? It's not installed on my computer. Now if I do Chromium, it's gone. I have a cleanup thing. So because I haven't said my computer needs Chromium, on Monday when I start the computer, it will wipe Chromium, the code from there. This is so that it's cached. So if I run Chromium once more, it will run fast rather than downloading it again. So yeah, that's Coma. So I wanted to show how NixOS modules work and how easy it is to share. So I made this NixOS module called Telepathy Nix. And what it does is basically it converts your OS into a Vijay themed OS. So just a disclaimer, I did this as a joke. I didn't expect the guy to actually win the election. So now it is more serious, but it's there. So I'm going to show you how you can do that and how we can kind of mess around with it. So let's see. So again, I have a fresh system here. So I'm just going to go into etc NixOS. Let's get into sudo so commands are more easier. And do shell. Cool. So I'm just going to say that I want my telepathy configuration. I already just have it here for time's sake. And I wanted to get in the outputs, and then I want the module to be enabled. Now, if I do that, and I do a NixOS rebuild boot, the thing is, NixOS, Telepathy Nix is like very heavy, like very eager in telepathifying things. So if I do it in the active running system, it will kind of break the system a bit. Again, this is not very stable. The license is literally saying. Like I have set a license according to that as well. I just say that good luck with that. The author has no clue what happened here because I just wildcarded this with Claude live at FOSS Meet. So I don't know what is happening here. It will probably be broken. So it's there. I said NixOS rebuild boot. So what that basically means is next time I boot into the new OS. So we'll do that. I won't be able to share the audio, but if the audio was there, it would be more cool. I don't know if you'll hear it through the mic. One of the advantages of vibe coding is the grub will be broken, but it's there. Now, the next time I boot, my boot animation is going to come, hopefully. It takes a second. Yeah, you can have Vijay coming out of water boot animation. This is the boot animation. Of course, all Vijay fans will know this. And then, I don't know if the audio will come out through my system, but like when I log in, you can. Yeah, only after that intro is played and this thing comes in, it sets the wallpaper as well. And it comes into that. There's a custom XFCE theme. You can see there's like a telepathy T here. I even wanted to like write NeoFetch, but I didn't get the time to do that. But I'm trying to kind of like, but like, for example, there's a canon that telepathy uses NeoVim because that's the telepathy text editor. So if I go into NVim, you can see that this is telepathy Vim. And, it's basically my configuration, but I was able to kind of do that. Now, the more amazing thing is, okay, one day I decide that my system has become too much telepathified and done. Maybe I switch sides to some other actor. Maybe like I become a Surya fan or something, or a Rajinikanth fan or something, and this doesn't work for you. It's very easy to kind of like switch back. So you can just, I didn't go to sudo. Let me just go ahead and comment this. Good. And you do that, and you do an NixOS rebuild boot again. It's going to remove telepathy Nix, but it's not going to do it in this version again because I said reboot boot. Now, if I reboot, that same customization that was applied to different programs. So this is not just to one program, right? This is applied to a lot of different programs, and all of them will be cleanly removed. Yeah, this will be there. This is a bug with XFCE where it kind of remembers what the old wallpaper was. But if I log in, that will be wiped and that becomes actually the proper thing. Right? So we are back into vanilla XFCE again. So I was able to install this. Again, there's no concept of install. You declare and then you uninstall and then you basically get that out. And that's kind of the idea. So you can make changes. You can happily make changes, do whatever you want. Once you have broken the thing, you can come back. You can restore, work or towards it. You can edit things out. And that's kind of the idea with NixOS, right? It's a system that you cannot generally break. It's a very strong system where you can do whatever you want. You can hack into things, but be able to kind of do it in a very piecemeal way where you can still recover your system and get the best of both worlds. So that's basically it for presentations and this stuff. I think I can take questions if anyone has any. So yeah, this is kind of QA time. So if you guys have any questions, I'll be taking them now. You can. I'm using Kali in live pen drive. Can I use Nix like that in stable mode? You can. You can. I mean, yeah, you can do it. So yeah, you can try that. I'm pretty sure there should be guides around that sort of topic. Maybe people have done that. I haven't personally done it, so I don't know how complicated it's going to be. But it's doable. Anything you can do in a resistor, that should be doable in NixOS. It's just a matter of figuring out how to tell that to Nix to build an OS in that way. That's usually the annoying part. So yeah, but I'm pretty sure you will be able to do that. I mean, if you think about it, like the ISO file is something you and kind of like mount, and that is a full NixOS system that you kind of install it. NixOS has a proper graphical installer, so you can do that. It's actually a really cool installer also because that same USB actually has both GNOME and KDE. So when you're installing, you can decide whether you want to use the installer with GNOME or installer with KDE. So the funny thing is it has both GNOME and KDE in the installer together at the same time. But the more funnier thing is even with that, it is actually smaller than the Ubuntu installer ISO. I don't know how that happened, but yeah. So yeah, you have that. So because the USB runs a live NixOS, you should probably also be able to install NixOS in your pen drive. But I'm pretty sure it won't be like a very straightforward operation compared to like installing normally. But I think if you install Kali on a pen drive, you already know that it won't be straightforward. Any other questions? I think I'll stop screen sharing it because I don't have anything else to share. Okay, I think if we are good with that, then we can wind up. I think everyone's good then.
Okay. Ashwin, Andrew, shall you wind up?
So, as we bring the session to a close, I'd like to extend my sincere thank you to our speaker, Andrew Bastin, for sharing his expertise in Nix and NixOS. And thank you to all the participants for joining the session. Thank you.
All right. Thank you, guys. Bye bye.